Hi and Assalamualaikum. My name is Nozatun Hafiza binti Nur Ashmawi. My metric number is A22L0244. Today, I want to present introduction for statistics. Statistics is a branch of mathematics that deal with analysis, summarizing, and interpreting group data. There are three variables in the data description like good, bad, and medium. Based on the table above, there are several calculations to find the means, median, and so on, based on the data that have given using advertising, population, price, and age. Table 1 shows the calculation for condition of good. The total frequency is 400, the percent is 100, and the cumulative percent is 100. Table 2 shows the calculation for population. The total frequency is 401 and the percent is 100 and the cumulative percent is 100. Table 3 shows the calculation for age. The total frequency is 401, the percent is 100 and the cumulative percent is 100.
Assalamualaikum, my name is Nura Anisa binti Zaharizal and my matrix number is A22A1265. For table 1, sales group frequency, the total is 115 and the percent 100%, same like the value percent, and cumulative percent got 100% also, as well as the calculation method for other tables too.
Assalamualaikum and hi, my name is Nur Imani Nazarifah binti Abdul Halim. My matrix number A22A1107. For this part, I will explain about number 3, descriptive measures. We have 3 important titles that we have calculate. For the example title is measure of central tendency and measure of position and also measure of variation. We have used for sales, income and also price. For 3.1, they are a table for measure our central tendency, for median, mean, and also mode. We must use a class of width of sales is 1.75. We must find the mean. Formula for mean is fx divide n. So the answer is 1131 divide for 5150. The answer for mean is 7.54. For median, location of median class is n divide 2. Observation is 150 divide for 2 observations. We have made the median class is 7.00 until 8.74. For the example, Lm plus n divide 2 minus Fm minus 1 and divide Fm. And then we need to times with C. So the answer of median of sales is 1.215. So for mode, we have to find the answer is also use LM is 6.5 and use for mode class is 7.00 and until 8.74. And then use the formula they given and the answer is 6.75 for the mode of sales.
Next is measure of central tendency, have mean, median, and mode. The total for mean is 71.87 and total for median is 73.68 and the total for mode is 85.99. Other than that, measure of position. Total for Q1 is 37.50. Total for Q3 is 112.50. After calculate Q3 minus Q1, the total is 43.20. Also, measure of variation of income. For the total for S2 is 73.05. The total for S is 26.89.
Next, I will explain for 3.3 measure of central tendency, measure of position, and also measure of variation of price. We have used the class width of sales is C 20.9. For the explanation, Q1 is equal to N4. For the Q1 is 1504 and the answer Q1 is 37.50. We must use class interval is 24 until 44.8. Next, for Q3 equal to 3 and 4. Q3 is 3 times 150 and also times 4. So for the answer Q3 is 112.50. So the class interval that we have to use is 107.56 until 128.44. Next, we have to find value of Q1 and also Q3. For the formula, Q1 equal to LQ1 plus N divide 4 minus F, and then divide FQ1 and then times with C. So the Q3 is 107.06 plus 112.5 minus 45, and then divide 112, and then times with 20.39, and then we get the answer is 117.53. For the interquartile range, Q3 minus Q1. So 117.53 minus 786.35. So the answer is negative 668.82.
Hi, Assalamualaikum. My name is Muhammad Ibn Hakim bin Hamid. My metric number is A22A0907. Today, I'm going to talk about graphical representation. Graphical representation refers to the visual presentation of data using graph, charts, or other visual elements. It is a technique for condensing and visualizing data to make complex information easier to comprehend and use. Our group using three types of graphical representation, which is number one is bar chart. Bar chart is when comparing discrete categories or groups. Bar charts are frequently employed and are especially helpful for displaying the relative size of various values. They are extensively used for data visualization and interpretation in a variety of disciplines, including business, economics, statistics, and many more. Alright, number two is histogram. Histogram is when attempting to visualize the distribution of continuous data. Histograms are especially helpful. They aid in the determining the general structure of the data set as well as pattern and trends. The histogram form can reveal information about the distribution features, such as whether it is symmetric, skewed, or several peaks. And last but not least, our group using a scatter plot. Scatter plot is in many disciplines such as statistics, economic, biology, and the social science. Scatter plots are used extensively to find patterns, outliers, and possible trend in data. They offer a useful visual aid for comprehending the connection between two continuous variables.
Hello, my name is Nuriza Binti Marzuki. My metric number is A228046. Today I will talk about point 5, which is statistical analysis using software. The software that will be used is SPSS. First is numerical description measure. The one statistic sign on the top is calculated using the SPSS, while the other table is calculated manually. As you can see, both tables has almost same value with a little differences. For the sales group, the median by using the SPSS is 7.5750 and the manually is 8.21 with a difference of 0.635. For the income group, the median by the using SPSS is 73.0 and manually is 73.68 with a difference of 0.68. For the price group, the mean using the SPSS is 113.8.40 while the mean by manually calculated is 107.29. The data were recorded from mean to third quartile. This is a bar chart by using the SPSS software to show the value of sales. While this is the histogram graph by using the SPSS software to show the value of incomes. This is the scatter plot by using SPSS software. As you can see from the graph, the x-axis represents the midpoint while the y-axis represents the frequency. The midpoint must calculate each class lower and upper bounds to get the midpoint answer. After calculating the midpoint, each midpoint must be compared to the frequency of each class and the total frequency must equal to the sample size, which is 150 of the data sets. Next one is hypothesis testing. In the table, there are various categories such as sales, income, and price. The DF of the categories remain unchanged at 149. The t-test for the sales is 32.281, indicating that the mean sales is 0.5. And the confidence interval of the difference for the lower is 7.04 and for upper is 7.96. For the income group, the t-test is 32.71, indicating that the mean sales is 71.1996 and the confidence interval of the difference for the lower is 67.62 and for the upper is 76.31. For the price group, the t-test is 61.64, indicating that the mean sale is 7.50 and the confidence interval for the difference for the lower is 109.9 and for the uppers is 117 and 18. T-test for pair 1. There are 5 steps to complete. The answer we get for T is negative 78.889. T-test for pair 2. The answer we get for T is negative 57.123. T-test for pair 3. The answer we get for T is negative 14.490. ANOVA for all variables. This is the test of homogeneity of variance which we calculate by using SPSS software. This is output SPSS. The decision that we get is fair to reject the HO since 1.239 is less than 1.36. This means that based on the available data, we cannot conclude that the group membership has a significant impact on the either sales or income.
A statistic method for determining the relationship between two variables is a correlation analysis. The relationship between two variables is referred to as correlation in statistics. Data can be seen in the ANOVA table.
My name is Nurain Masita binti Abdul Azaib. My metric number is A22A0444. 5.4 confidence interval. By using the SPSS, we obtain the 95% confidence interval for income lower boundaries 0.005 and the upper boundary 0.036. The standard error for this dependent is 0.008. Besides that, it can be said that 95% confident that the income parameter is between 0.005 and 0.036. 5.5 Prediction modeling. First scatter plot. Graph 1, income and sale have a weakly positive relationship. This suggests that as income rises, so do sale. However, the relationship is not particularly significant. Graph 2, income and price show a weak positive relationship. This suggests that price rise in tandem with the income but a somewhat weak correlation. Graph 3, there is a strong positive correlation between sale and price. In contrast to the other two graphs, this one indicated the substantially stronger correlation between price increase and sale increase. The data point form a much closer cluster around the trend line. Sale and income have a small positive correlation, 0.253. This demonstrating that more income is associated with more sale, through the relationship is not substantial. Price and income have a moderate negative relationship, negative 0.148. It is not statistically significant, indicating that it is more likely due to chance that the Gini link. Sale and price have a slightly negative correlation, negative 0.405, implying that as a price rise, so do sale. This correlation is statistically significant. Test of normality. The Shapiro will test of normality on the sale give a p-value of 0.01, which is less than 0.05. Thus, the assumption of normality of the term of the sale is met. Next, model summary. The R-square value is 0.202, which means 20.2% of the variation in the sale group can be explained by the income group and price group. Adjusted R-square is lower than R-square value, which is 0.191. This indicated that the model is slightly overfitting the data, even though the difference is small. The value of standard error of the estimate is 2.55894, which is the average difference between the actual and forecasted sale numbers. ANOVA, statistical significance, the p-value is less than 0.001, indicating that it is very significant. This suggests that there is an extremely low likelihood, less than 0.1, that the observed association between the predictor variable, income and price, and the sale variable is due to chance. Model significance. The model, which include income and price, explains sale in a statistically significant way. At least one of these factors influence sale significantly. Breakdown of variability. Explanation of correlation in sale. The model account for 244.184 units of variance. residual unexplained, the model does not explain 9962.579 unit of variation in a cell, implying that additional factor impact cell. Last one is coefficient, constant. The regression equation intercept is 11.3796, which represent the predicted sale value when both income and price are zero. Income has a coefficient of 0.021, implying that for every unit rise in income, sales should increase by 0.021 unit while leaving price constant. However, its p-value is somewhat higher than the standard signification level 0.05, indicating that there is a less evidence for its impact. Price has a coefficient of negative 0.047, which means that for every unit rise in price, sales are predicted to fall by 0.047 unit while income remains unchanged. This is a statistically significant link. Concluding remarks. The study used various methods to calculate the value data of selected descriptive variables for sale, price, and income initial. The data was compiled using frequency distribution, relative and cumulative frequency distribution, and graphs such as histogram, bar chart, and scatter plot. Manual computation and SPSS system were used to describe the data set with numerical descriptive measure. The mean, median, and mode of income we calculated manually using the measure of center tenders, while the SPSS computation slightly different result due to inaccurate data reading. Hypothesis we tested using the independent sample t-test and the ANOVA table with the 5 basic produced in the correlation analysis was conducted using scatter plot and correlation table. The study also discussed the use of graph to think about model and pattern, demonstrating confounding and how multivariable model can be used to control for it. Statistics play a vital role in all aspects of life, and understanding this discipline is essential.